entry point you can just specify as main. You don't have to do any sort of constructions or anything like that to run main. Your stack is set up, everything is done to run, your program is loaded. The only thing that's really used for is dynamic libraries, but we don't care about that so much. So that's not too bad, 158 bytes, a little bit bigger. So we go back to our original code, and we can take a look at it. Now we're doing a lot of things here, not so much of a lot of things. We're opening up a file, opening up dev audio. That can be done with a system call. We have the format structure that we're doing passing to IOCTL. We have a macro that builds that for us. This macro actually calls memset. That's the only library that this macro calls. So if we replace memset, we don't need that library. Then we have an IOCTL. We write a lot right here. That's it. We print stuff out, and we're really not doing much else. So we can pretty much replace all these things with syscalls. That's what this looks like. I have these installed. I just write open IOCTL. And we're replacing open, for instance, with our sys function. And it should just work. The problem is we're also calling the math library as well. As you can see, we have written memset, so we're replacing math. And the only other thing that we're doing is we are calling find, so we can replace that. Push the argument on the stack to a floating point find, pull up the stack into rect and return it, and that replaces our find. If you look at the disassembly of find, a lot more code than that, albeit this is equivalent. It's kind of strange. And the rest of the code really doesn't call anything. And then at the very last bit, we compress it. We stick our uncompressed header onto it, make it a shell script. We have our program, which is 2.3K, so that's not bad. And it runs. So that's cool. We've compressed a program that was 15K into 2K. And perhaps this is a little short, but I believe I'm done with my presentation. Do you have any questions?
You find yourself scooping out all kinds of unnecessary code out of other applications?
Out of other applications? Yeah, there's some demo programs that have source code. I was going to show you a couple of demos, and I figured that would keep the time. But we're fortunate in Linux because we can do that. We're fortunate in Unix because we can do that. We're fortunate because we have a relatively easy syscall. You can make syscalls relatively easily. Now, Linux being Windows being proprietary, maybe they have as an efficient way of making syscalls, but no one does it. And I suspect no one, if the interface changes through versions, I'm sure it's like, I've never seen anyone make syscalls with Unix. Do we have a, yeah?
Can I get a hold of the code?
Yeah, sure. I can put it on the drive there for you.
Cool.
Any other questions, perhaps? This is our section header. we have a name index. We're not using sections, but we have another section that is devoted to strings. And then we have an index into that section for strings. So we don't have to put out, we can have a fixed, this happens to be a long, fixed size reference string that way. We have a type. Is it executable? Is it page loaded? We can specify whether things are page loaded or not, which is very strange. An address. This is the address relative to what program header this is in. File offset again, and a size, which is very nice. You can put anything anywhere in the file you want. It's a very simple file format. Address alignment, had info. This is not used for anything. Info. The specification says info. I believe that's 16 bytes, which possibly means itself. And also entry size. We can have different size of a section versus the size that it is in memory. We can have a section with a 0 size. That's the BSS section, which is just 0. It's not in the file. We just fill memory with 0. This is our program section. Again, pretty simple. We have memory alignment, the loadable section, and the loadable program section. The virtual address, the physical address. The reason why we separate the virtual address and physical address is if we're loading something from a ROM perhaps, and we have the data segment in the beginning of the ROM, despite the fact that it is loaded somewhere else in memory. So you want to have the symbols match where it is in memory. Memory size, file size, again those can be different, and memory alignment as well. So they're very similar sections. Do we have any other questions?
So, question.
Yes.
If I wanted to start doing this stuff, where do I start to look to find out all this stuff about ELF files?
Demo scene. Demo scene. It's not too big in the States, but it's huge in Europe.
But demo scene is just like a bunch of demos. Is there articles on it, like how to do this stuff? Or?
There is actually a wiki, 4K, in 4K, dot, undergrund, undergrund.org, and that is a wiki how to do this in other operating systems as well as Linux. Does anyone want to run a 1K demo?
Sure.
Seriously, anyone have internet access? We'll download one and we'll stick it on here. Can we do this from you?
Go ahead.
Do you have a pretty good graphics card?
I have a great graphics card. I don't have graphics card.
You have a great graphics card. Is that Linux?
No, but I have Linux on a virtual box.
Anyone have a graphics card with drivers? That's important. You want to come up?
My Mac has great drivers. My Linux VM doesn't have acceleration though.
Actually, we'll show a 4K.
I can do software with it. I mean, I don't know. Yeah.
The problem is it's a Pixel Shader 3 program.
Oh, yeah.
So
That'd
that's
be only
my graphics card right there. Just a note about graphics cards. Holy crap. Holy crap. You can do real-time ray tracing in a graphics card.
Since when?
Since like 4 years ago. Since it's a massive parallel computer. It's since Pixel Shader 3 model came out, I think that was 2006. And you can have a program that can have different size for loops, jump wherever the fuck you want. Just a pretty general purpose program, albeit it has no communication with adjacent pixels. But every pixel runs this program, and when it's done, so you can do ray traversal for every pixel.
Yeah, but is that, will that work with a number of a spectral number of triangles? I mean, that's
It's
the
not
thing.
triangles though, it's spheres and ray
Pixels.
tracing. It's using different geometry.
Well, I know, but I mean, the bottom line is, I don't know, maybe if they want to better say it, but I mean, every geometric shape that we're going to try would put 3 volts on a corner. Isn't that